Hello, everyone, and welcome back. In this video, we're going to be talking about connecting infinite limits and vertical asymptotes. So when we're dealing with any function that has a denominator, if we set that denominator to 0, that creates a vertical asymptote. Now, we've seen that before. Now, in this video, we're going to have a look at how can we connect that to infinite limits. So let's say, for example, your function is f of x is equal to 1 over sine x, right? And we consider sine x, and when sine x is equal to 0 to create our vertical asymptotes, well, sine x is equal to 0 when, is equal to 0 when x is equal to, well, it happens in the first, x is equal to 0, and then it happens again at pi, again at 2 pi, again at 3 pi, 4 pi, and so on, right? So we can say x is equal to n pi, basically, or 0 plus n pi, so basically n pi. So so you're saying that every vertical asymptote is going to be happening at x is equal to n pi. So if I were to sketch out a graph with a vertical asymptote, right? So if this is my graph with my vertical asymptote right here, let's not put it right underneath me. So let's say this is my graph with my vertical asymptote, right? So here's my x-axis, my y-axis, and imagine the vertical asymptote happens at over here. This is pi, okay? So this is one of the vertical asymptotes that we're talking about. And over here, so x is equal to pi. Now, what happens is you're considering the behavior before and after. So if the behavior looks like this, right? So if our behavior looks like this, so our function is approaching infinity, for instance, as it comes from the left side, and from the right side, it's approaching, let's make that a little closer. So from the left side, it's approaching negative infinity, okay? Now, if our function is behaving like this, so our left-hand limit, right? Our left-hand limit as we come from the left side is approaching, we said infinity, and our right-hand limit is approaching negative infinity, right? Now, what would we say about the general limit, right? Like, because we always considered the left-hand limit and the right-hand limit. What had to be true? It had to be equal for us to have a general limit. So in this case, we don't have a general limit. So the general limit does not exist, right? Now, if they were going in the same direction, then yeah, it would exist. So if I were to kind of graph another graph over here, imagine this was now our graph. Oh, I don't like that. Let's try it again. If this was now our graph and we have something that's behaving like this, right? Now, if I can see that from the left-hand side, so our left-hand limit is equal to our right-hand limit, then now we can say that and they're both equal to infinity, for instance. And then now we can say that the general limit is equal to infinity as well, because the left-hand limit and the right-hand limit are both approaching infinity. So our general limit is then we're able to say that our general limit is infinity. Same thing if we said the left-hand limit, if the left-hand limit was equal to the right-hand limit, but they were both approaching negative infinity, right? So if I have a situation like that, then I can also say that the general limit is equal to negative infinity. So this is how we're just connecting both, right? Now you've seen working with general limits before. The only difference now is that we're considering what's happening when we have a vertical asymptote, okay? All right, everyone, I hope that helped, and I'll see you in the next video. Bye.